So this lesson is going to be on solving inequalities by testing the sections. And how are we going to test the sections? By using a number line. I feel like we've done this lesson a couple of times now, so a lot of what we do here is going to make sense. We just have to make sure that we follow the steps carefully and test the sections nicely. So right here we have a rational function, and we want it to be greater than or equal to 0. Okay, guess what we're going to do first? That's right, we're going to factor the denominator. So we've got x minus 1 as a factor in the numerator, and we've got x plus 2 times x minus 2, and greater than or equal to 0. Okay, so the first thing is you want to make sure everything's on one side and you have your 0, which we do. And the reason you want a 0 is so you could say if you want positive or negative. And in this case, where is the graph greater than 0? So we want positive. When we did the parabola chapter, we drew little parabolas because that was fast and easy. But when we have these fancy rational expressions, we're not going to draw a whole graph just to see where it's greater than 0. So what we're going to do is use a number line. And on the number line, we're going to put all the critical values. Okay? So we take a look here. A critical value from the numerator is 1. We're going to put that on the number line. We also have plus and minus 2. Negative 2 and positive 2. So there's something critical that happens at these places. Okay, there's an x-intercept, which means the graph is either above or below at that point. These are vertical asymptotes. There's no graph even there at all. The next thing I want to know is whether we should put open or closed bubbles. And the way that we figure that out is by looking at the sign. Greater than or equal to 0, so I want to make sure that they're equal. So at 1, we're going to put a closed bubble. Plus and minus, even though not have the denominator equal to 0. So those are going to get open bubbles. So as a reminder, if it comes from the denominator, the bubble is always going to be open. That's right. Okay, and now it's time to test the section. There's something happening with the graph here. Something happening here. These are critical values. Something happens with the graph. It changes from positive to negative or something like that. So let's go ahead right here and pick a number in this section. I'm going to test the value x equals negative 10. So I'm going to take negative 10 and I'm going to plug it into each set of these parentheses. Negative 10 minus 1 is going to be negative, who cares? Okay. Negative, who cares? Negative 10 plus 2, that's going to be negative. And negative 10 minus 2 is also going to be negative. A negative times a negative, that's going to cancel out, make a positive. A negative divided by a positive is going to be negative. Okay? But we want positive. So this is not a good section. Right here, this next section between negative 2 and 1, I'm going to test the number 0. So in the numerator, so we've got 3 sets of parentheses. If you put 0 in, that first set of parentheses comes out to be negative. This set of parentheses down here on the left is going to be positive, and this one here is going to be negative. And a negative divided by negative makes a positive. And that's what we want. So this right here is a good section. You have to test all the sections carefully. You don't have to put numbers. You could just say positive, negative, okay, but you have to do something. This section right here, we're going to have to test between 1 and 2. Let's do 1.5. Okay, so you have to have 3 sets of parentheses. 1.5 minus 1, that's positive something. 1.5 plus 2 more, that's positive. 1.5 minus 2 is negative. A positive divided by negative. This section is negative. That's not what we want. This last section right here, I'm going to test a value more than 2. I'm going to test 100. Why am I going so big? Sometimes it's just a little more obvious when you're calculating numbers. 100 minus 1 is definitely positive. 100 plus 2 is positive. 100 minus 2 is positive. So this section is positive, and that's what we want. Okay. All of this stuff right here, this is all of the work. Okay. But we have to officially write down the answer. Okay. So the answer for this problem is this section right here, and I'm going to use interval notation. From negative 2 with parentheses all the way until 1 with brackets. Oh, and some more, so let's say union, starting at 2 with parentheses until infinity, and infinity always gets parentheses. Okay. What I'm going to do now is write down the steps for testing the sections that you should follow for all the problems that are rational like this. So the first thing you're going to do is set the equation equal to 0. If the equation isn't already 0, on one side, move everything else over. Okay, step 2 is to factor completely. Factor completely. Okay, so you get your critical values. Step 3 is to put those critical values, on a number line. Okay. What you're going to do here for step 4, if it's less than or equal to, or greater than or equal to, you use a closed bubble. For the zeros, or the critical values, from the numerator. Only from the numerator, not from the denominator. Okay? Always use open, open bubble, for zeros from the denominator. What if it's just less than or greater than? Then everything would get an open bubble. Okay, and step number 6 is you have to test the sections. Okay, and you could just do that with plus and minus, but you have to put positives or negatives in the parentheses, and then you want to see, is it greater than or equal to 0? Or is it less than or equal to 0? Or what do you want? And that's how you test. Okay, here's another example right here. Step 1. Set the equation equal to 0. And I'm noticing that this problem doesn't have a 0. So this 6 over x has to get moved to the other side. So 6x minus 5, switch sides, switch signs, less than 0. Okay, that's good. Everything's set equal to 0. Step 2, we have to factor. Now this is not really in rational form. Rational means it's a fraction. So I'm going to have to make some common denominators here. So the common denominator between 1 and x is x. So this middle term right here needs to get multiplied by x over x. This first term needs to get multiplied by x over x. And so we have 6x squared minus 5x minus 6, and the common denominator is x. Don't forget to say less than 0. Make sure it stays an inequality. Okay, now I can factor. So the numerator, let's see, has to get factored. The denominator is quite simple. It's just an x. Okay, less than 0. Go ahead and take a couple of seconds there to get that factored. So it's going to be 3x times 2x to make a 6. You got to make a negative 5. So I think it's going to be plus 2 here, minus 3. Let's check. Does positive 2 times negative 3 make your last? Of course, but it's the middles we really have to check. Your outers are negative 9, and the inners are positive 4. Does that make negative 5? Of course. Okay, so we factored completely. Step 2 is complete. Okay, next, put your critical values on a number line. So what are the critical values? The denominator gives us 0. This factor right here gives us a critical value, or a 0 of 3 halves. 3 halves. And this one right here gives us negative 2 over 3. Okay. Put the critical values on a number line. Got it. Make sure you put them in order from smallest to greatest, like a number line would go. 0 comes from the denominator. Remember what I told you to put? If it comes from the denominator, always use what kind of bubble? Yes, an open bubble. If they come from the numerator, it depends. Okay, it depends on the sign. In this case, it's a less than sign, so we're going to use open. Okay, once again, denominator always gets open. And the top depends. Depends on the sign right there. Okay, critical values. I've got my open bubbles. I've got my closed bubbles. Okay, it's time to test the sections. And now it's time to find some good numbers right here. A number that's less than negative 2/3. I guess you could pick negative 1, right? That's less than negative 2/3. So we have 3 sets of parentheses. Negative 1 times 3. Negative 3 plus 2, that comes out to be negative. Negative 2 minus 3, that's another negative. And the bottom, of course, is negative. A positive divided by negative is negative. Now, what did we want? This rational graph right here has to be less than 0. So we want negative. And we got negative. Okay, so this is a good section. Please color it in and the arrow because it goes forever. Please make sure I could tell your colored section versus your not colored section. Okay, it could be that 2 in a row are colored in this case, so you need to test all sections carefully. All right, let's see. What is between 0 and negative 2/3? Maybe I'll try negative 1/3. Okay, 3 sets of parentheses. Negative 1/3 times 3, that's going to be negative 1 plus 2, that's going to be positive. Negative 2/3 minus some more, that's definitely going to be negative. The bottom is just x, that's a negative. Negative divided by negative is positive. That's not what we want, not a good section. Section number 3, this is 1.5, so I'll try the number 1. Okay, and this is the work that I want to see. You could put numbers or just plus and minus signs if you want. 3 plus 2 more is going to be positive. Who cares? 2 minus 3 is just going to be negative, and that is what we wanted. So let's go ahead and color that one in. And finally here, a number bigger than 1.5. Oh yeah, let's try 100. Let's try 100. What's 300 plus 2 more? Positive. 200 minus 3, that's positive. Divided by a positive. Sometimes it's obvious if you go big. This section is positive, but that's not what we want. Okay, this number line and all this testing is great work, but now we have to officially state the answer. This section right here on the left goes from parentheses negative infinity up to negative 2/3 with parentheses. And there's another piece, so union. I've got parentheses 0 up to 3/2. And that's how you state the answer when solving an inequality, a rational inequality. All right, let's keep going. We've got a couple more here. This next one looks like it's already factored for us, which is great. Oh, the denominator needs to get factored. Okay, so let's go ahead and write this all out. This is 3 minus x. Oh, it's 3 minus x 3 times. Oops. 3 minus x. And then we've got 2x plus 1. The bottom is a difference of cubes. So we're going to go ahead and sop it up. The little guy, the binomial, is x minus 1. Who remembers this? Come on, guys. X squared. Sop it up, put plus 1x. Always put plus 1. And this is less than or equal to 0. Okay, so on our number line now, where are the critical values? I know there's one at 1. What critical value do we get from this guy? Nothing. Nothing. Oh, this one right here is going to be negative 1/2. If this is not obvious right here, 3 minus x, you can go ahead and solve that by hand. 3 minus x equals 0. And then negative x is equal to negative 3. Divide both sides by negative. So the value is 3. Does that make sense? 3 minus 3 makes a 0? Yes. So our last critical value is 3. Okay. Open or closed bubbles. 1 came from the denominator, so he gets an open. All the time gets an open. The ones that came from the numerator depend on the sign. And in this case, let's close them up. Let's close them up. And now it's time to test the sections. Okay, we're going to test this value right here. We could go big or go home. Maybe I will test negative 100. Sure, why not? Now the question is, do you want to write it 3 times? Or write it as quantity cubed and try to figure that out? Maybe I'll just write it all in factored form here. 1, 2, 3, 4. let's see, negative 100. 3 minus a negative. That's going to be positive. And positive, positive, all the same. How about negative 200 plus 1? That's going to be negative. Here, you could either do factors, or you could go up to this difference of cubes. A negative 100 cubed is negative, so that's going to be a negative down here. And this is going to be positive. Do we want positive? Looking at this problem, we want negative. Okay, so this section is no good. Right here, oh goodness, what are we going to test? Negative 1/4. All right, negative 1/4. 3 minus a negative. Well, that's going to be positive. Positive, positive, positive. What's this factor here going to be? Negative 1/2 plus 1. That's going to be positive. Let's go up here. A negative 1/4. A negative times a negative times a negative is going to be negative 1 over, what is that? 16 times 4, that's 64. A negative fraction minus some more, that's definitely going to be negative. So this section is negative. Oh, that's what we want, so here's a good section. Okay, right here, I think the best value would be 2. 3 minus 2 is positive, 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 times another positive. I think I want to test the difference of cubes again. 2 cubed, 8 minus 1, that's a positive, but that's not what we want. And here, you could go big or you could go small. Do you want to test something like 5? 3 minus 5 is going to be a negative. And then this factor's a negative, and this one's a negative. I'm going to write them out because that might make a difference. I didn't write it when it was plus, plus, plus. 10 plus 1 more, that's going to be a positive. And 5 times 5 times 5 minus 1 is a positive. So this section ends up being negative. Oh, that's what we wanted. Okay, now it's time to write our answer. So the red pen answer is between brackets, negative 1/2 up to 0, union, brackets, 3 to infinity. Always put parentheses on the infinities. Okay, this next one. What were the steps to solving? You have to make sure that you first make a 0. So we're going to go ahead and subtract x. Step 2, what are those steps? Set equation equal to 0. Factor completely. All right, let's factor this thing. The first thing I notice is I can take out an x, and that's x cubed minus 1. After that, a difference of cubes. So we've got x is our first factor. X minus 1 is the second factor. I feel like we just did this up here. X squared plus x plus 1 greater than 0. All right, what critical value is this going to give us? That's right, nothing. Okay, so when we go look at our number line, we're only going to have 2 critical values, 0 and 1. Okay, I notice that there's no denominator, it's just a numerator. Since it's greater, these are going to be open bubbles. And now it's time to test. So this first section right here, I'm going to test something less than 0. How about negative 1? Okay, you can test any of the equations that have quantities. So you could do that negative, who cares, times positive, who cares. So you can't use this one. You can use either the second one or the third one. And I think I'm going to use this one right here, just because this is less work than doing 2 factors there. So negative 1 makes the first set of parentheses negative. Negative 1 cubed is negative, minus some more is negative. This section comes out to be positive. And what did we want? Okay, looking right here, we want positive. So this is a good section. Okay, the next value I have to test here is going to be a fraction. I guess I'll go with 1/2. So there's 2 sets of parentheses. The first one is just the 1/2 positive. 1/2 times 1/2 times 1/2, that's 1/8. 1/8 minus 1. 1 is like 8 over 8. This section is going to be negative, and that is not what we want. Right here, the next section I'll test is 10. The first parenthesis is positive. 10 times 10 times 10 minus 1 is still positive, and that is what we want. That is what we want. Okay, time for the final answer. Okay, this is a great number line, but the answer is from negative infinity to 0, union 1 to infinity. Okay. This last one right here does not have a 0, so the first thing that we're going to have to do is move the 3 over to the other side. Okay, move the 3 over, minus 3. Then we have the 0. Now we're going to have to make common denominators here. The common denominator, let's put parentheses around all these quantities. I've got an x plus 2 quantity and a 1. The common denominator is going to be x plus 2. You have to show me non-denominator, but you distribute a negative 3. So the numerator is 4x minus 5 minus 3x minus 6. The common denominator was x plus 2. Don't forget to finish the inequality, please. Let's add some like terms. X. Oops, I made a mistake here. This is supposed to be plus 5. Plus 5. Ooh, catch that. Positive 5 minus 6 is negative 1. Oh, this rational expression here is turning really small. So our number line is only going to have two critical values. Negative 2 from the bottom and 1 from the numerator. Do I put an open or closed from the critical value from the denominator? Always put an open. The numerator depends. Looking at this sign, let's put a closed bubble, okay? And we want positive. Positive. I want you to go ahead and test these sections, okay? And I want you to go ahead and write your answer here in a box for me to check tomorrow, okay? You are left with testing those 3 sections. Okay, good luck.